So we're continuing topic 6.12, where we are looking at partial fractions and integration. We're going to look at this one. I would definitely write small. I'm probably not going to be able to write small enough to fit it all in there, but I would write small on this one because we have to do an extra process to begin with, because we're going to start with a long division and then we have to do partial fractions. So here's my long division to begin with. So I know I'm going to have the 2x cubed minus 4x squared minus 15x plus 5. And then I've got x squared minus 2x plus 8 on the outside. I ask myself what times x squared is 2x cubed. So that would be 2x. And then I'm going to distribute that through. So 2x times x squared is 2x cubed. 2x times negative 2 is negative 4x squared. 2x times 8 is 16x. And then we're going to swap all of our signs. So we'll notice our first term cancels, our second term cancels, and our third term, did I write? Oh, I have a typo. Glad I caught that, because it made our arithmetic a lot easier. It was supposed to be minus 8 right there. And so when I distribute through, I get negative 16. So when I swap our signs, I have positive 16. So negative 15 and positive 16 is positive x. And I drop down the 5. So I can't divide an x squared into an x, so that becomes the remainder. So I have x plus 5 over x squared minus 2x minus 8. So now I am integrating 2x plus 5 over x squared minus 2x minus 8. So dx. So now this piece in the back is where I have to do the partial fraction decomposition in order to get that into something that I can integrate better. So I'm going to do that work off to the side. See if you can squish it in the left-hand column or below here, as we only need like another line to do that integration. So I'm going to start with a magic x. So two numbers that multiply to negative 8 and add to negative 2 would be 4 and 2, and the 4 has to be negative. So I know that my denominator of this is x minus 4 times x plus 2. So I am finding a fraction. I'm splitting this into x minus 4 and x plus 2 with the a and the b on the top. I'm also going to write those values here, so I've got them for later. All right, I'm keeping the x plus 5, and I'm setting that equal to. I'm just going to multiply by what's missing. So I've got an x plus 2, and I'm going to distribute the, if I can get it to work, I'm going to distribute the a, so I get ax plus 2a. And then in the second one, I'm missing x minus 4, so I'm going to distribute the b, so plus bx minus 4b. And then we're going to we have 1, a, and b. So 1 equals a plus b. And then our second equation, I have a 5, a 2a, and a negative 4b. So 5 equals 2a minus 4b. And I'm going to solve. So I'm going to solve for the b, so I'm going to subtract. So I'm going to subtract the b, so I get 1 minus b equals a. And then I am going to substitute this in for the a. So I get the 1 minus b in there, and now I'm going to distribute the 2. So I get 5 equals 2 minus 2b minus 4b. And then I end up with, I'm going to subtract the 2, which gives me 3. And then negative 2b and negative 4b is negative 6b. I divide by negative 6, which means that b is going to be equal to negative 1/2. So that means this piece is negative 1/2. I'm just going to put it in front. And then I'm going to put in, yeah, that's right. And then I'm going to put in the 1 minus 1/2, 1 minus negative 1/2. The double negative is going to go positive. I'm going to pretend that's 2 over 2. So a is 3/2. So I'm going to put a 3/2 in front of this one. And we're going to go ahead and integrate. Remember, those fractions are just coefficients. So when I integrate, I get 2x squared over 2. And then we know that the 1/overs are all going to be natural logs when we integrate. So plus 3/2 natural log absolute value of x minus 4 minus 1/2 natural log absolute value of x plus 2 plus c. And I could go ahead and reduce these 2's and just make it x squared.